All right, so this is problem number 3 on the test review. Your company sells exercise clothing and equipment on the internet. To design the clothing, you collect data on the physical characteristics of your different types of customers. We take a sample of 31 male runners and find their mean weight to be 71.79. So here we have a sample size. Here we have an X bar, because this is a sample mean. Assume that the population standard deviation is 4.5. A health magazine claims the average weight of male runners is 73.5. So here's the claim. This is what we believe to be true. Is there statistical evidence that alpha equal 0.05 to suggest that the runners weigh less than 73.5 kilograms? All right, so the null hypothesis, number 1. HO. Well, the belief is, all right, the general belief is that mu equals 73.5 kgs, kilograms. Now, some of you are going, hey, how come it's not the 71.79? There's a simple answer to that I think will help you out a whole lot. The simple answer is that came from the sample. Anytime it comes from the sample, it's X bar, and X bar will never go over here, ever. X bar never goes over here. So consequently, because that came from the sample, it's the X bar and it'll never go over here. The alternative hypothesis, we know it's going to be a mu, and we know that this is going to be 73.5, but we need to make a determination whether it's a less than, greater than, or not equal to. Well, in this case, they say weigh less. So that tells me I'm working with a less than. The next thing on the recipe asks me to define my parameter. So let mu equal the true population mean weight of runners. Truly, it's a true population mean weight of runners at that store, but that'll be good enough for our purposes. Then we need our conditions. Well, they took a random sample. We know that we have a sample size 31 or larger, so it's normal by central limit theorem. But for this class, all we need to do is write assumed. The next thing we need to do is write, number 4 is to write our equation. So our equation is Z equals X bar minus mu sigma divided by the square root of n. Now we need to draw our graph and shade, which is number 5. So drawing my graph. Well, the claim is our center at 73.5. That's the mu. But we got a value that's something lower at 71.79, and that's our X bar. And because this is a less than, we're shading off to the left. The next thing says enter the data. Next thing is number 6. It says enter the data. We don't have to have data. So the next thing we need to do is list and label all of the input values. Okay, so our input values, in this case, we have the mean, which is 73.5. We have a standard deviation, which they told us was 4.5. We have an X bar equal to 71.79. And our sample size is 31. So number 8 tells us to plug our values into this equation. So we want the probability that Z is less than, because this is the symbol, X bar, so 71.79 minus our mean of 73.5. over 4.5 divided by the square root of 31. So once we've done that, we're going to calculate our z and p-values. So I'm going to go stat, test, and it happens to be a z-test, so number 1. And we need to enter 73.5, the 4.5, the 71.79, the 31, and we need a less than symbol. When we do that, we end up getting the probability that z is less than negative 2.1157 equals 0.0171. And this is our p-value. So we now have our p-value. And they gave us alpha above. They told us up here, somewhere up here, they said alpha equals 0.05. So we're just go ahead and write that down here. Alpha 0.05. Now let's make them the same length. This is 4 decimal places, so I'm going to make this 4 decimal places. Well, 500 is bigger than 171, or 171 is less than 500. So when I look down, we've done number 8, we've done number 9, so now we're on to number 10, where we need to state our decision. If the p-value is less than alpha, we reject the null. So our decision is simply reject the null. And that's number 10. Then we need to write our conclusion. And our conclusion is this. Our p-value is 0.0171. We reject the null. There is sufficient evidence at alpha equal 0.05 to suggest that the true population mean weight of runners is, well, what was our alternative? Less than 73.5 kgs, is less than 73.5 kgs. So basically, we said, you know what? We ended up with a really small p-value, so we're rejecting the null. We no longer believe that they weigh 73.5 kilograms. We have enough evidence to say that they weigh less than 73.5 kilograms. We're not saying they weigh 71 kilograms or 70 or 72. We're just saying that they weigh less than 73.5. That's what we have evidence to show. The next thing we need to do is we need to go ahead and calculate a 97% confidence interval. All right. So we've already done number 1, which is define the parameter. So number 1 gets a check because it's done. We've already done 2, which is write the conditions. So that gets a check. We have not written the formula for the test. So here's our formula. Our formula, which is number 3, is X bar plus or minus Z star, standard deviation of the population, divided by square root of n. So that right there is my the formula. They ask us to enter data. We don't have data to enter. So then we need to come up with our list of things that we have to put in. Well, we need to put in the standard deviation. We need to put in the X bar, and we need to put in our sample size. But I'm going to go ahead and list these down here. And I'm going to sit there and go, you know what? My standard deviation, 4.5. My X bar, 71.79. And then we have an N of 31. The next thing it asked me to do is it asked me to calculate Z star. So this is number 5. And Z star, to get Z star, I'm going to have to do a second var's inverse norm. All right, because they gave me an app. So here we go, second var's inverse norm. And we're just going to go parenthesis, 1 minus 0.97 divide by 2, mean of 0, because every time you're working with a Z, mean of 0, standard deviation of 1. And we're going to calculate, and we get 2.1700. So our Z star equals 2.1700. The next thing we need to do is plug into our equation. And so when I do that, when I plug into this, I end up having 71.79 plus or minus my Z star. We always make it positive. So always write it as positive, especially when you're putting it into the worksheet. And this is 4.5, the standard deviation, divided by the square root of 31. So now we're going to go ahead and calculate this, and we're going to go stats test Z interval. And I have 4.5, 71.79, N of 37, and a confidence level of 0.97. So this ends up being my interval. So number 8 is 70.036, comma, 73.554. The next thing it asks us to do, and you may not have room on your paper, and I don't, so I'm going to have to get a separate sheet. So I'm going to have to do this on a separate sheet of paper, is I need to go ahead, every time you do a confidence interval, you should write out its conclusion. So we are 97% confident that, I want to box this off so you can tell what I'm doing, that the true population mean weight of runners lies within the interval, and our interval was 70.036 to 73.554. Now, one thing I want to say about that interval, the lowest plausible value is 70.036, and the highest plausible value is 73.554. And the midpoint, or the middle of that interval, is X bar. And X bar is always in the middle. So you might even want to just draw that there to remind yourself, X bar is always in the middle. Unfortunately, it asks us to interpret the confidence level. And so I'm going to have to do that on a separate sheet of paper. And what that is saying in repeated sampling. So you need to show this as well, right? So we're going to need to do this because I need it. Anytime it asks for me to interpret the confidence level, I have to do so. In repeated sampling, We expect this method to capture the true population mean weight of runners 97% of the time. Okay, so in repeated sampling, we expect this method to capture the true population mean weight of runners 97% of the time. Now, that answers the part up here where it says interpret the confidence level. That's not writing the conclusion. The conclusion I was able to fit in, and I wrote, we are 97% confident the true population mean weight of the runners lies within the interval. This happens to be number 9 right here. That's number 9 on the recipe card versus this is number 10. You only have to do number 10 is that if they asked for it, and here they said interpret the confidence level, so I had to do it. Finally, it says, based on the interval you calculated, is the claim of the magazine plausible or reasonable? Justify. Well, what was their claim? Their claim was the average weight was 73.5. And my question to you is 73.5 located in the interval? Well, 73.5 is definitely above 70, and it's less than 73.554, so it lies in the interval. So I'm going to say 73.5 lies in the interval. The magazine claim is plausible. All right, 73.5 lies in the interval, so the magazine claim is plausible. All right, so this will conclude for question number 3. Question number 4 will be in the next video. If I can figure, there it is.